warm greetings to all. I'm Dr. Jyothirmayi, Head and Assistant Professor, Department of Geography, Nirmala College for Women. In this video, we are going to watch about the interior of the Earth. Let's move on to see what is inside the Earth. What are we walking on? Earth is unique among the known planets. It has an abundance of water. In other words, including a few moons, have atmospheres, ice, and even oceans. But only Earth has the right combination to sustain life. Earth's oceans cover about 70% of planet's surface with an average depth of 2.5 miles, that is 4 kilometers. Fresh water exists in liquid form in lakes and rivers and as water vapor in the atmosphere, which causes much of Earth's weather. To begin with, we will see the formation of Earth. We all know that Earth formed approximately 4.6 billion years ago. Early Earth lacked an atmosphere. Later on, meteors and asteroids bombarded the Earth and the atmosphere was formed. So our early Earth grew from a barrage of extraterrestrial impacts, increasing in mass over time. In the early stages of planetary accretion, Earth was much less compact than that it is today. The accretionary process led to an even greater gravitational attraction. Gravitational energy was then converted into heat. Radioactive elements, which were unstable, and over time became more stable. Radioactive decay processes released heat. So the initial accretion led to an homogeneous sphere that eventually became densely stratified with the heavier iron and nickel sinking to the center of the Earth, and the lighter silicates floated to the top. Now, to explain the physical structure of the Earth, the core, mantle, and crust are the divisions based on composition, and the lithosphere and asthenosphere. These divisions are based on mechanical properties. Lithosphere, which is a rigid outer layer, and asthenosphere is a solid rock that flows slowly like hot asphalt. Lithosphere is the outermost mechanical layer which behaves as a brittle, rigid solid. Lithosphere is about 100 kilometers thick. The definition of the lithosphere is based on how Earth materials behave. So it includes the crust and the uppermost mantle, which are both brittle. Since it is rigid and brittle, when stresses act on the lithosphere, it breaks. This is what we experience as an earthquake. Asthenosphere is partially molten upper mantle material that behaves plastically and it can flow. This is the layer below the lithosphere and it is plastic-like, and the rock exhibits plasticity, that is the ability to flow, and it can also be said as malleable. In terms of plate tectonics, this layer is very, very important. And enormous heat and pressure is generated in this layer. Next is mesosphere, which is located below the asthenosphere. Meso means middle. Now, Earth's interior layer, as I already told you, core, mantle, and crust based on composition of the Earth. The crust. Earth's outer surface is its crust, a cold, thin, brittle outer shell made of rock. The crust is very thin relative to the radius of the planet. There are two very different types of crust, each with its own distinctive physical and chemical properties. Oceanic crust is composed of magma that erupts on the seafloor to create basalt lava flows or cools deeper down to create the intrusive igneous rock gabbro. Sediments, primarily muds and the shells of tiny sea creatures
coat the seafloor. Sediment is thickest near the shore where it comes off the continents in rivers and on wind currents. Continental crust is made of many different types of igneous, metamorphic, and sedimentary rocks. The average composition is granite, which is much less dense than the mafic igneous rocks of the oceanic crust. Because it is thick and has relatively low density, continental crust rises higher on the mantle than the oceanic crust, which sinks into the mantle to form basins. When filled with water, these basins form the planet's oceans. Next layer is the mantle. The two most important things about the mantle are it is made of solid rock and next it is hot. Scientists know that the mantle is made of rock based on evidence from seismic waves, heat flow and meteorites. The properties fit the ultramafic rock peridotite, which is made of iron and magnesium-rich silicate minerals. Peridotite is rarely found at Earth's surface. Scientists know that the mantle is extremely hot because of the heat flowing outward from it and because of its physical properties. Heat flows into two different ways within the Earth: conduction and convection. Conduction is defined as a heat transfer that occurs through rapid collisions of atoms, which can only happen if the material is solid. Heat flows from warmer to cooler places until all are the same temperature. The mantle is hot mostly because of heat conducted from the core. Convection is the process of a material that can move and flow and may develop convection currents. Convection in the mantle is the same as convection in a pot of water on a stove. Convection currents within the Earth's mantle form as material near the core heats up. As the core heats the bottom layer of the mantle material, particles move more rapidly, decreasing its density and causing it to rise. The rising material begins the convection current. When the warm material reaches the surface, it spreads horizontally. The material cools because it is no longer near the core. It eventually becomes cool and dense enough to sink back down into the mantle. At the bottom of the mantle, the material travels horizontally and is heated by the core. It reaches the location where warm mantle material rises and the mantle convection cell is complete. Next layer is the core. At the planet's center lies a dense metallic core. Scientists know that the core is metal for a few reasons. The density of Earth's surface layers is much less than the overall density of the planet, as calculated from the planet's rotation. If the surface layers are less dense than average, then the interior must be denser than the average. Calculations indicate that the core is about 85% iron metal with nickel metal making up much of the remaining 15%. Also, these metallic meteorites are thought to be representative of the core. If the Earth's core were not metal, the planet would not have a magnetic field. So the metals such as iron are magnetic, but rock which makes up the mantle and crust is not. Scientists know that the outer core is liquid and the inner core is solid because the S waves stop at the inner core. The strong magnetic field is caused by convection in the liquid outer core. The convection currents in the outer core are due to heat from the even hotter inner core. The heat that keeps the outer core from solidifying is produced by the breakdown of radioactive elements in the inner core.
Hope all of you understood the contents of this video. Thank you for watching.